Chapter 10, Application of Differentiation. Okay, the first subtopic, 10.1, Extremum Problems. So the learning outcomes of today's lecture, students should be able to find critical points, relative finding extremum using the first derivative test, finding extremum using the second derivative test. So you can read through yourself the introduction. So let's look at the critical points. Critical points in the form of x, fx. Okay, it is in the domain of the function. Okay, and either f prime x 0 or f prime x does not exist. So please make sure you know what do we mean by critical number. Number referring to values of x, and critical value, value referring to value of the fx. Okay, so we have two conditions. When f prime x 0, that's where we have the tangent to the curve parallel to the x-axis, so you can refer to these diagrams. And also we have the f prime x does not exist. That's when we have the dy dx equals to plus minus infinity, or dy dx does not exist. So you can also refer to these graphs. Let's continue to the first example. Find the stationary points and stationary values of the function fx here. Okay, the first step is you need to get your f prime x. So differentiate fx, you will get 6x squared minus 6x minus 12. Okay, for stationary points, f prime x equal to 0. So we will have 6x squared minus 6x minus 12 equal to 0. Factorize 6. So x squared minus x minus 2. Factorize further. X minus 2, x plus 1. So we have x equal to 2 or x equal to negative 1. So when x equal to 2, so get the value of your fx. So substitute 2 cubed minus 3, 2 squared minus 12 times 2 plus 7. So you will get the value to be negative 13. When x equal to negative 1, fx will be 2 negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 plus 7, and you will get the value to be 14. Hence, stationary points are 2, negative 13 and negative 1, 14. Stationary values are negative 13 and 14. Let's move on to the second example. So we need to find the f prime x. So f prime x equal to, so we need to use the quotient rule. So this is in the form of fraction. So we need to use quotient rule. So list out your u. Your u will be 9x squared minus 36. So u prime will be 18x. So v will be x squared minus 9. So v prime 2x. Okay, start off with v. So x squared minus 9. U prime 18x minus u 9x squared minus 36, and then v prime 2x over x squared minus 9 squared. So simplify, we will get it to be negative 90x over x squared minus 9 squared. So for critical numbers, So we have f prime x equal to 0 or f prime x does not exist. So negative 90x equal to 0, you will get x 0. So when f prime x does not exist, that's when the x squared minus 9, 0. So factorize. Okay, x minus 3, x plus 3. So x 3 or x negative 3. So hence, critical numbers are 0, 3, negative 3. Right. So for critical points, we only have critical points when the f prime x 0. Okay, so we need to get the corresponding value of the fx. So when x 0, f x will be, so substitute 90 squared minus 36 over 0 squared minus 9. So we have 4. So hence the critical point is 0, 4. First derivative test. So let C be the critical number. Okay, so f is continuous at x equals to c and differentiable on the open interval I containing c. Okay, f prime x changes from positive to negative at c, so it is relative maximum. If f prime x changes from negative to positive, it's relative minimum. If f prime x does not change sign, so it has no relative extremum. So you can refer to the graph here. So this is maximum, this is minimum. So here no relative extremum because it doesn't change sign. So this is positive, positive. So this is negative, negative. So the first two, this is positive, negative. This is negative, positive. Okay, so the step to use the first derivative test. So find the derivative of fx. So f prime x, get it? Determine all the critical numbers. That's when the f prime x equal to 0. So you get values of your x. Then you need to determine where the fx increase or decrease. Meaning, so increase when the f prime x the value is positive, decrease when the f prime x the value is negative. Then you look at the relative extremum based on the changes of the sign. So if you have positive to negative, so meaning positive, negative, so you have maximum. So if you have negative to positive, so that will be minimum point. Right, let's continue with the first example. Okay, y equal to 3x power 4 minus 4x cubed. So find your dy dx. So 12x cubed minus 12x squared. For relative maximum and minimum, dy dx equal to 0. So 12x cubed minus 12x squared equal to 0. Factorize 12x squared. So x minus 1. So we have x 0 or x equal to 1. So next, draw a table. So this is interval. So you have 0, you have 1. So this is between 0 and 1. This is 1 to infinity, negative infinity to 0. Okay, second row, we have x. So this is half. We have here 2, we have negative 1. So this is where we have the dy dx and conclusion. So substitute into your dy dx. We have negative value here, also negative and positive. So this is, the gradient is negative. This is also negative and positive. So at x0, there is no relative extremum at x0. But x equal to 1, so you have the minimum point. So let's find the value of the y. So when when x1, so y equal to 3, 1 power 4 minus 4 times 1 cube. So you get negative 1. So hence the relative minimum point is 1, negative 1. Let's look at the second example for the first derivative test. So if you look here, this is in product form. So we need to use product rule. So we're going to let u to be 3x plus 2. So u prime is 3. So v is e negative x. So v prime is negative e negative x. So f prime x will be 3x plus 2 times negative e negative x plus e negative x 3. So factorize e negative x. So negative of 3x plus 2 plus 3. So we have e negative x 1 minus 3x. So bring down the e negative x. So we have 1 minus 3x over ex. So for relative extremum, f prime x equal to 0. So 1 minus 3x equal to 0, x equals to 1 over 3. So for the denominator, so ex always greater than 0. So hence, f prime x always exists for all x. So we only need to draw the table, to use the table for x 1 over 3. There's only one value. So this is 1 over 3 infinity, negative infinity to 1 over 3. So choose a value of your x. So 1, negative 1. So here will be f prime x and conclusion. So you will get here to be positive, negative. So the gradient positive, gradient negative, slanting to the right, slanting to the left. So we have a maximum point here. So we need to get the corresponding value of your fx. So when x equal to 1 over 3, so what is your fx? So what f of 1 over 3, so substitute. So we will get 3 times 1 over 3 plus 2 e negative of 1 over 3. So 2.15 to 3 significant figures. Hence 1 over 3, 2.15 is a relative maximum point.